The Fermi paradox. Right now, somewhere above you, light is arriving that left its source before the pyramids were built. The sky looks calm. It looks empty. But it has been waiting, for longer than anyone can really imagine, to hear something back. There are over 100 billion stars in our galaxy alone. Around many of those stars there are planets. Some of those planets sit in the right spot, not too hot, not too cold, the kind of spot where water can stay liquid and life can maybe get started. Multiply that out across billions of years, across hundreds of billions of galaxies, and the math gets strange. The numbers say the universe should be loud. It should be full of signals, full of light from other civilizations, full of someone, somewhere, saying hello. Instead, there is nothing. No radio signals, no messages. No proof that anyone else has ever looked up at their own sky and wondered the same thing you're wondering right now. Scientists call this the Fermi paradox, named after a physicist who, during a lunch conversation in 1950, simply asked, "Where is everybody?" He wasn't joking. He had done the math, and the math said we shouldn't be alone. And yet, every direction we point our telescopes, every signal we wait for, comes back the same way. Silent. And that silence starts to feel less like an empty room and more like a held breath. Because here's the part that creeps into your mind late at night. If the universe is old enough and big enough, then someone should have come before us. Someone should have spread out, building, traveling, signaling by now. Unless something stops them. Unless there's a wall somewhere out there, an invisible filter that almost nothing gets past. Maybe it's behind us. Some impossible step early life rarely survives. Or maybe, and this is the colder thought, maybe it's still ahead. Maybe every civilization reaches a certain point, gets the same tools, the same power, and ends the same way. So when you look up tonight, you're not just looking at stars, you're looking at a kind of test result. Billions of chances, and as far as we can tell, only one answer that ever said yes. You are living proof that it's possible, but nobody has told you yet if it's common, or if it's a fluke, or if it's something that simply doesn't last. Maybe the silence isn't because no one is out there. Maybe it's because something happens to everyone who gets this far. And if that's true, the real question was never, are we alone? It was always, quietly, how much time do we have left before we understand why? Dark matter. Everything you can see, every star, every planet, every galaxy spinning slowly through the dark, is only a small piece of what's actually there. Light shows you maybe 1/6 of the universe. The rest is invisible. It doesn't shine. It doesn't reflect. It doesn't do anything light can touch. And yet it's the thing holding everything else together. Scientists call it dark matter, but that name is almost a confession that we don't really know what it is. We only know it's there because of what it does. Galaxies spin too fast. Stars near the edge of a galaxy should fly off into space the same way you'd go flying off a merry-go-round, spinning too quickly. There isn't enough visible mass to create the gravity needed to hold them in place. Something else is pulling, something we can't see, can't touch, and can't detect with any instrument we've built so far, is wrapped around every galaxy like an invisible hand, keeping it from tearing itself apart. Think about that for a second. You can point a telescope at a galaxy and see beautiful spirals of light, billions of stars, and what you're looking at is the smallest part of the picture. The actual shape, the actual skeleton holding it together, is invisible. We are floating inside a structure we cannot see, made of something we cannot name, that outweighs everything we can name by about 5 to 1. And it's not just out there, it's here. Right now, scientists believe dark matter is passing through this room, through your body, through your bones, completely unnoticed. It doesn't interact with regular matter, not in any way we can feel. You could be sitting inside a silent stream of it at every second of your life, and never know. So somewhere above your own head, galaxies are being held in shape by a force with no name, no light, no explanation we've managed to catch yet. And somewhere inside your own body, that same invisible thing might be quietly passing through you as you lie here, listening to this. We built civilizations, wrote down the laws of physics, sent machines to other planets, and we still don't know what most of the universe is made of. We are explorers, standing in a room 5 times larger than what we can see, feeling along the walls in the dark, hoping that one day our hands will finally touch what's already touching us. Dark energy. There is a number that should worry you more than it does. Right now, every galaxy in the universe is moving away from every other galaxy, not drifting, not coasting, accelerating. Something is pushing the universe apart, faster and faster, and that something makes up almost 70% of everything that exists. We call it dark energy. Not because we understand it, but because we don't. In the late 1990s, astronomers were studying distant exploding stars, expecting to confirm that the universe's expansion was slowing down after the Big Bang, the way a ball thrown into the air eventually falls back. Instead, they found the opposite. The expansion was speeding up. Galaxies that should have been gently coasting apart were flying away from each other faster with every passing year. It was like watching a tossed ball rise higher and higher instead of falling. Here's the part that's hard to sit with. This isn't a force acting on space. It seems to be a property of space itself, empty space, the nothing between stars, between galaxies, between you and the edge of the observable universe, isn't actually empty. It has its own energy, pushing outward, and the more space that exists, the more of this energy there is, which makes more space, which makes more energy. It feeds itself. There is no engine driving this. There is no source we can point to. There is simply space, expanding into more space, for reasons we cannot yet explain. And it never stops. While you lie here, the distance between our galaxy and our farthest neighbors is quietly growing. Slowly, imperceptibly. But it adds up, over billions of years, into something almost unbearable to imagine. One day, and one day here means trillions of years from now, the other galaxies will move so far away, so fast, that their light will never reach us again. The night sky, for whoever or whatever exists then, will go almost completely dark. Not because the stars die, because the space between us and them will have stretched too far for their light to ever cross it again. So when you picture the universe, don't picture something fixed, something solid, something safe. Picture something quietly pulling itself apart, second by second, for a reason no human being has ever managed to name. We gave it a name anyway. Dark energy. Mostly so we'd have something to call the thing that is slowly, gently erasing the universe's ability to ever talk to itself again. What happened before the Big Bang? Ask someone what happened before the Big Bang, and you'll usually get one of 2 answers, either a confident nothing or an awkward silence. Both answers are hiding the same uncomfortable truth. We don't actually know. And depending on how you look at it, the question itself might not even make sense. Here's the strange part most people never hear. The Big Bang wasn't an explosion happening inside space, like a bomb going off in a room. It was the beginning of space itself. Before it, there was no room for anything to happen in, no emptiness waiting around, no clock ticking in the dark, counting down the seconds until everything began. Time itself, the very thing that lets one moment lead to the next, appears to have started at that same instant. So when you ask, what happened before, you're asking about a before that may have never existed at all. It's like asking what's north of the North Pole. The question feels normal. The answer is that you've run out of map. Some scientists picture it differently. They imagine our universe as one bubble in an endless, frothing sea of other universes, popping into existence and collapsing over and over, forever. Others picture time as a loop, with our Big Bang simply being the bounce point of a previous universe that crushed itself down to nothing and sprang back outward like a ball compressed past its limit. And some physicists, the ones willing to say the quiet thing out loud, admit that the equations simply break down at that first moment. The math hits a wall. It cannot see past it. We are trying to look at the very first page of the universe's story, and the page is torn off. Sit with that for a moment. Everything you have ever known, every person, every memory, every star and grain of sand, sits on top of a beginning we cannot see past. We can trace the universe back to a fraction of its very first second, almost the entire history of everything, mapped out in careful detail. And then, right at the edge, the trail simply vanishes. So the universe has a birth certificate with no listed parents, a first moment with no recorded before. And somewhere in that gap, in that torn-off page, is the answer to where all of this, you, this room, this exact second, actually came from. We may never get to read it, but it's strangely comforting to know that even the universe itself doesn't seem to remember how it began. The edge of the observable universe. No matter which direction you point a telescope, you will eventually hit a wall. Not a wall made of stone or metal, but a wall made of time itself. It's called the edge of the observable universe, and it isn't really an edge at all. It's a limit on how far back we're able to see, because light, even light, needs time to travel, and some things are simply too far away for their light to have ever reached us. Here's the number that's hard to hold in your head. The universe is roughly 13.8 billion years old, so you'd think the farthest we could see is 13.8 billion light years away. But space itself has been stretching this whole time, expanding while that light was on its way to us. So the actual edge of what we can observe sits about 46 billion light years away in every direction. Beyond that, there could be more stars, more galaxies, more of everything, stretching on forever. We simply have no way of knowing, because their light hasn't had time to reach us yet, and it never will. Now picture this. You are sitting at the exact center of your own observable universe. Not because you're special, but because everyone is. Someone standing on a planet 40 billion light years away has their own personal edge, their own 46 billion light year bubble, with themselves sitting quietly at the middle of it. Their bubble and your bubble barely overlap. They are looking out at galaxies you will never see. You are looking out at galaxies they will never see. There could be 1 trillion of these bubbles, 1 trillion centers of 1 trillion observable universes, each one convinced, in a strange and lonely way, that they are the middle of everything, and the gap between us is growing. Space is expanding faster than light can cross it, which means there are galaxies out there right now that we can never reach, never see, never even prove exist, because the space between us and them grows faster than light could ever close it. Some of them may have already slipped past the edge of what we'll ever be able to observe, gone from our view forever, even though they still exist. So somewhere out past that 46 billion light-year wall, there could be entire galaxies, entire histories, entire skies full of stars that no eye, no telescope, no mind will ever witness. Not because they aren't real, but because reality itself is simply too big to ever finish unwrapping. Black holes and the death of information. Imagine writing a letter, sealing it in a bottle, and throwing it into the ocean. No matter how far it drifts, no matter how deep it sinks, somewhere, in some form, that letter still exists. The universe, as far as physics is concerned, doesn't like to forget things. Every event, every collision, every flicker of light leaves behind a trace that could, in theory, be read backward to figure out exactly what happened. Nothing is ever truly erased. Except maybe in one place, black holes. A black hole forms when something collapses under its own gravity so completely that it creates a point where nothing, not light, not matter, not information itself, can escape. Anything that falls in disappears behind what's called an event horizon, a one-way door with no handle on the inside. And for a long time, that seemed simple enough. Things fall in, they're gone, end of story. But physics doesn't like that ending, because it breaks one of its most sacred rules. Information isn't supposed to vanish. It can be scrambled, hidden, locked away almost beyond recognition, but it's not supposed to be deleted from existence completely. Here's where it gets unsettling. Black holes don't last forever. Slowly, over unimaginable stretches of time, they leak energy and shrink away through something called Hawking radiation, until eventually they evaporate completely. So picture it. Something falls in, carrying all its information, its complete history with it. The black hole eventually evaporates into nothing. So where did the information go? If it's truly gone, then the universe broke its own rule for the first time ever recorded. If it somehow escaped, smuggled out in that faint radiation leaking off the edge, then everything we thought we understood about the inside of a black hole needs to be rewritten. This is called the information paradox, and it has quietly tortured some of the smartest physicists alive, not because it's just a puzzle, because of what it implies. If information can be destroyed, then the past isn't fixed. Cause and effect start to wobble. The universe stops being something you could, even in theory, run backward like a recording. So somewhere out there, in the crushing dark at the center of a dying star, there may be a place where the universe's memory simply gives out. A place where the past stops mattering, where the question, what happened here, no longer has an answer waiting to be found, not hidden, not locked away, just gone. And we still don't know if that's something the universe is even capable of doing. Heat death of the universe. Right now, the universe is doing work. Stars are burning. Galaxies are colliding. Energy is moving from hot places to cold places, powering every single thing that happens, including you, lying here, breathing, thinking, listening to this sentence. But work like that has a cost. Every single time energy moves, a little bit of it becomes unusable forever. And given enough time, an unthinkable, almost unbearable amount of time, that cost adds up to everything. This is called the heat death of the universe, and it isn't an explosion or a bang. It's the opposite. It's a fading. Scientists describe it using something called entropy, which is just a way of measuring disorder, or more simply, how spread out and used up energy has become. Right now, the universe still has plenty of contrast left. Hot stars next to cold space, bright galaxies next to dark voids. And contrast is what allows anything to happen at all. Heat death is what happens when that contrast finally runs out completely. Here's how it unfolds, slowly, in stages too long for any mind to truly picture. The stars burn through their fuel and go dark, one by one, until the last red dwarf, the slowest, most patient stars in existence, finally flickers out. After that, even the black holes, the most patient objects in the universe, eventually evaporate away into nothing through a process so slow it makes a star's lifetime look like a single heartbeat. What's left is space, empty, cold, almost perfectly even space, with no more hot or cold left to push against, no more energy left that can do anything at all. At that point, the universe doesn't stop existing. It just stops happening. No new stars, no new thoughts, no more moments, because a moment requires change, and there is nothing left able to change. Time would technically continue, but with nothing left to mark its passing, even time starts to feel like a meaningless word. And the strange part is, this isn't a fringe theory. This is, as far as current physics can tell, the most likely ending of everything. Not fire, not collapse, just a long, gentle fade into stillness until the last flicker of usable energy in the entire universe is spent. So somewhere, unbelievably far in the future, the universe will finally go quiet, not because anything destroyed it, but because everything it had to give, every bit of light, heat, and motion, will have simply, quietly, been spent. Are we living in a simulation? Right now you are completely certain you're real. The bed beneath you, the air you're breathing, the sound of this voice, it all feels solid, undeniable, true. But here's the uncomfortable question some of the smartest people alive can't quite shake. What would it actually feel like if none of that were real, and you were simply a very, very convincing illusion? This isn't science fiction anymore. It's a serious argument, one built carefully by philosophers and physicists, and it goes something like this. Imagine that, someday, far in the future, civilizations become advanced enough to build computers powerful enough to simulate entire conscious minds. Not just graphics, not just a video game world. Actual minds that think they're alive, that feel pain, that fall in love, that lie awake at night wondering if they're real, with no way of telling the difference from the inside. Now ask yourself this. If even one civilization, anywhere, ever, manages to build that, they wouldn't stop at one simulation. They'd run thousands, millions. Far more simulated minds would exist than original biological ones, which means, statistically, if simulated minds are even possible at all, you are far more likely to be one of the many copies than the one original. And the unsettling part is, you'd have absolutely no way to know. A simulation convincing enough wouldn't feel fake from the inside. It would feel exactly like this, like sitting here right now, fully convinced of your own reality, simply because that conviction is the easiest, most efficient feeling for any mind to have, real or not. This is where the logic turns the world a little sideways. Physicists studying the universe have already found that reality seems to run on rules, mathematical, clean, almost like code. Some have even noticed strange limits, like a kind of pixelation at the smallest possible scale of space, that some say resembles the underlying structure of a simulation more than a naturally occurring universe. Nobody can prove it either way. But the fact that it's even a real, serious debate, that brilliant minds have looked closely at reality itself and walked away unsure, should tell you something. So here's the question that doesn't have a comfortable answer. If you can't prove you're not a simulation, and the math suggests simulated minds would outnumber real ones, then on what grounds exactly are you so sure this is the original copy of existence, and not simply one of the many, quietly running somewhere, convinced, like all the others, that it's the real thing? The Boltzmann brain problem. Here's a thought experiment that, once it gets into your head, is almost impossible to shake. What if the universe didn't need billions of years of stars and galaxies and evolution to produce a mind like yours? What if, statistically, the easiest way for a conscious mind to appear isn't through all of that effort, but through pure random chance, popping into existence alone, in the middle of empty space for no reason at all? This is called the Boltzmann brain problem, and it comes from a strange corner of physics dealing with entropy, randomness, and unbelievably long stretches of time. Given enough time, truly enough time, far beyond the age of stars or galaxies, the random jostling of particles in empty space can, purely by chance, occasionally arrange themselves into almost anything, including, in an almost unbearably small but real possibility, a fully formed brain. Complete with memories, complete with the sensation of a life lived. Floating alone in the freezing dark for a single fleeting instant before dissolving back into randomness. Now here's the part that physicists genuinely lose sleep over. If you compare how often the universe could randomly produce an isolated brain like this against how often it could produce an entire, ordered universe full of stars, planets, and billions of years of careful evolution, leading to a mind like yours, the math is lopsided in a deeply uncomfortable way. A floating, randomly assembled brain is statistically far easier for the universe to produce than an entire orderly cosmos, which means, if you trust the numbers completely, a thinking mind is far more likely to appear as a brief, random accident in the void than as the result of an actual structured universe like the one you believe you're living in. So the question creeps in quietly. What if this exact moment, this thought, this memory of a life that feels so continuous and real, isn't actually connected to any of it? No childhood, no yesterday, no real planet beneath you. Just a single, impossibly unlikely arrangement of particles, briefly convinced it has a past, about to dissolve back into nothing the instant after this thought completes itself. Most physicists treat this as a sign that something is broken in our understanding of the universe, not as literal truth. It's used more as a warning flag than a prediction. But the fact that the math even allows for it, that a fleeting, fake memory of an entire life is, in some strange cosmic accounting, more likely than the real thing, is the kind of detail that doesn't really leave you once you've heard it. So as you lie here, feeling like a continuous person with a past leading up to this exact second, ask yourself quietly, How would you ever know, from the inside, if this was the only second you ever had? Why, time only moves forward. Pick up a glass, drop it, and it shatters into pieces. You've seen that 1,000 times, but you have never, not once, seen a pile of broken glass gather itself back together and leap up into a perfect glass sitting on a table. The strange thing is, almost nothing in the basic laws of physics actually forbids that from happening. The equations work the same in both directions. So why does time only seem to move one way? This is one of the deepest, strangest puzzles in physics, and it's called the arrow of time. Most of the fundamental rules governing particles, gravity, motion, don't actually care which direction time flows. If you filmed two atoms colliding and played the footage backward, you couldn't tell which version was the real one. Both would look equally correct. And yet, somehow, in the real world, eggs don't unbreak, smoke doesn't crawl back into a chimney, and you don't wake up younger tomorrow than you are today. Something is clearly pushing time in one direction. The question is what? The leading answer comes down to probability, not law. Things tend to move from order into disorder, simply because there are so many more ways to be disordered than ordered. A glass has exactly one way to be a perfect, whole glass. It has millions of ways to be shattered. So when it breaks, it isn't because some law demanded it. It's because, statistically, disorder was always the more likely outcome. Multiply that idea across every particle, every interaction, every corner of the universe, and you get something that feels like a one-way arrow, even though, underneath it, there's no actual rule saying it has to be that way. Here's where it gets genuinely strange. This arrow of time seems to be tied to the very beginning of the universe. Right after the Big Bang, everything was in an incredibly precise, low disorder state, a strange kind of cosmic order that had nowhere to go but down. The entire flow of time, every memory you've ever formed, every moment that felt like it was leading into the next, may simply be the universe sliding down a hill of disorder it was placed on the top of, right at the very start, for reasons nobody fully understands. So when you feel time moving forward, when you feel like this moment is leading into the next one, you're not feeling some deep law of the universe. You're feeling the universe slowly losing its order and dragging you, gently, irreversibly, along with it. Multiverse theory. Right now, in this exact moment, there might be another version of you. Not a metaphor, not a thought experiment, an actual you in an actual place where some tiny decision went differently. Maybe you didn't read this sentence. Maybe you're somewhere else entirely, living a life built from 1,000 small forks you never even noticed taking. This is the idea behind the multiverse. And it isn't just one theory. It's several, coming from completely different directions in physics, all quietly pointing towards the same unsettling possibility, that our universe might not be the only one. One version comes from cosmic inflation, the extremely fast stretching that happened right after the Big Bang. Some physicists believe this stretching never actually stopped everywhere. It stopped here, in our patch of space, letting stars and galaxies form. But in other patches, it might still be happening, endlessly, creating bubble after bubble of new universes, each one its own separate reality, each one with no way of ever touching ours. Our entire universe, every star you'll ever see, might just be one bubble in an infinite, frothing sea of others. Another version comes from quantum mechanics, the rules governing the smallest particles in existence. At that tiny scale, particles don't seem to commit to one outcome until they're observed. Before that, they exist in a kind of blur of every possible outcome at once. One interpretation says that when that blur finally settles, it doesn't actually pick just one outcome. Instead, reality splits, quietly, instantly, into separate branches, one for every possible outcome, each branch becoming its own complete, fully real universe. Here's the part that's hard to sit with. If this is true, it isn't rare. It isn't happening occasionally, in big dramatic moments. It would be happening constantly, every time any particle anywhere makes a choice, which is happening an almost uncountable number of times every single second. Which means the universe might not be splitting once in a while. It might be splitting endlessly, right now, as you listen to this sentence, into branches you will never see, never visit, and never even know existed. So somewhere, in a place you can never reach, there could be another version of this exact night. Maybe you fell asleep already. Maybe you never started listening at all. Maybe, in some branch impossibly far from this one, none of this ever happened, and another you is living a life built from a single different choice in a universe quietly running parallel to your own, forever out of reach. Cosmic microwave background. If you could tune a radio to a frequency just past the edge of human hearing, far past any station, any broadcast, any voice ever recorded, you would still hear something. A faint, constant hiss, coming from every direction at once, with no source you could ever point a finger at. That hiss isn't static. It's the oldest sound, or rather the oldest light, in the entire universe, and it's been falling on Earth since long before there was an Earth to fall on. Scientists call it the cosmic microwave background, and it's essentially the afterglow of the Big Bang itself. For the first few 100,000 years after the universe began, everything was so hot and so dense that light couldn't even travel freely. It kept getting trapped, bouncing between particles, unable to escape, the way fog scatters a flashlight beam. Then, around 380,000 years in, the universe finally cooled enough for light to break free for the very first time. That very first burst of light is still traveling, stretched out now into faint microwaves, and it's still arriving, everywhere, all the time, including right here, right now, in the room around you. Here's the part that's almost too strange to picture. This isn't a signal from one direction, like starlight from a single star. It's coming from every direction equally, because it isn't coming from a place, it's coming from a time. You are essentially surrounded by the visible edge of the early universe itself, a glowing shell of ancient light wrapped completely around you, stretching out in every direction for over 13 billion years before it finally reaches your eyes, or rather, your radio telescope, since human eyes can't actually see it. And it isn't perfectly smooth. Tiny ripples, faint variations almost too small to measure, are scattered across this ancient light. Those ripples are the very first wrinkles in the universe, the seeds that eventually grew into the gravity that pulled gas together into stars, stars together into galaxies, galaxies together into everything you've ever known, including, eventually, you. So somewhere above you, right now, completely invisible, is the literal afterglow of the moment the universe became transparent for the first time. A faint, ancient light, older than every star you've ever wished on, quietly confirming, every single second, that there was a beginning, and that you, somehow, impossibly, are standing on something that grew out of its very first, faint flicker. Methuselah star. In a quiet corner of the sky, in the constellation Libra, there is a star that, by every careful measurement we've taken, appears to be older than the universe it lives in. Not a little older, not a rounding error. Older by what looked, at first, like nearly 1 billion years. A star that seemed to have existed before the thing that supposedly created it. It's called HD 140283, though most people know it by a more fitting name, the Methuselah star, named after the oldest man mentioned in the Bible. When astronomers first calculated its age, using the careful methods we use to measure how long stars have been burning, they got a number that didn't make sense, around 14.5 billion years old. The universe itself, as best we can measure, is about 13.8 billion years old. A star, sitting quietly in our own galactic backyard, appeared to be roughly 700 million years older than existence itself. Try to sit with that for a second. Not a galaxy far away. Not a strange signal from deep space. A star you could, in theory, point a backyard telescope at, that seemed to be carrying an age that broke the universe's own timeline. Either our understanding of how stars age was wrong, or our understanding of how old the universe is was wrong, or something about this particular star had quietly slipped through a crack in our model of time itself. Astronomers spent years refining the measurement, accounting for tiny uncertainties in distance, brightness, and the star's chemical makeup. Eventually, the numbers settled down to around 12 to 13 billion years old, just barely young enough to fit inside the universe's timeline, with the margins of error finally overlapping instead of contradicting. Crisis, technically, averted. But here's the part that lingers. For years, our most careful science looked at a single point of light and said, with real confidence, that it was older than time itself. And the only thing standing between that impossible answer and reality was the thin edge of a measurement error. Even now, the Methuselah star sits there, ancient beyond easy comprehension, a relic from the universe's earliest generation of stars, formed when the cosmos was still young, simple, and almost entirely made of hydrogen and helium. It has been quietly burning for nearly the entire life of everything that exists, watching galaxies form, watching our own sun ignite billions of years later, watching, in some strange sense, the birth of the very thing that would one day explain, however imperfectly, the impossible old age written into its own faint light. Rogue planets, wandering in eternal darkness. Picture a planet, mountains, maybe oceans, maybe storms sweeping across its surface, just like Earth. Now take away the sun, not block it. Remove it completely, along with every other star in any direction, leaving that planet drifting through open space with no warmth, no daylight, and no star to call its own. That planet isn't a thought experiment. It's a real common type of world, and it's called a rogue planet. Most planets, including Earth, form locked in orbit around a star, held in a stable, gravitational embrace that keeps them circling the same point for billions of years. But not every planet stays that way. Some are flung out violently by the gravity of a passing star, or a chaotic young solar system still sorting itself out, or even a near collision with another planet. Once that happens, there's nothing left to hold them in place. They drift outward, faster and faster, until they slip free of their star's gravity completely, sailing off into the emptiness between solar systems, never to return. Here's the part that's almost impossible to picture. Once free, these planets don't stop. There's nothing out there to slow them down. No friction, no resistance. Just an endless black ocean of space. They drift silently between stars for millions, even billions of years, completely alone. No sunrise, no sunset, no star ever rising over the horizon again. Some scientists believe rogue planets might actually outnumber the planets that are still orbiting stars, which means, somewhere out there right now, there could be more lonely, starless worlds drifting through the void than planets like ours, safely circling their sun. And it gets stranger. Some of these wandering worlds might still hold on to enough internal heat left over from their violent formation, or warmed by radioactive decay deep inside their core, to maintain a liquid ocean far beneath a frozen, pitch-black surface. An entire ocean, sealed away under ice, heated from within, with absolutely no light from above, ever. If life could exist there, it would evolve in complete and total darkness, never once looking up to see a star, because there would be no star to see. Not one, in any direction, for the rest of its entire world's existence. So somewhere out there, right now, a planet that once had a sunrise is drifting through permanent night, carrying maybe an ocean, maybe even something alive, sealed beneath the ice, moving silently through the dark, completely unaware that it was ever anything other than alone. The great attractor, pulling our galaxy. Right now, while you lie completely still, you are moving, not gently, not slowly. Our entire galaxy, the Milky Way, along with thousands of other galaxies around it, is being pulled, silently and relentlessly, toward something massive, hiding behind a wall of dust, gas, and stars so thick that we cannot actually see what's pulling us. Astronomers noticed it decades ago, not by seeing it directly, but by watching how galaxies were moving, instead of drifting apart evenly with the expanding universe, like you'd expect. Entire clusters of galaxies, including our own, were veering off course, all bending toward the exact same point in the sky. Something with an almost unimaginable amount of mass, roughly the weight of tens of thousands of galaxies combined, was sitting there, quietly bending the path of everything around it. They called it the Great Attractor, mostly because they had no better way to describe something they couldn't even look at directly. Here's the strange part. That region of sky happens to sit directly behind the dense core of our own galaxy, the Milky Way, where the view is blocked by an enormous wall of stars, gas, and cosmic dust, almost like trying to see what's behind a curtain made of light. For a long time, astronomers could feel its gravity pulling on everything around it, without being able to actually look at what was causing it. They were tracking a shadow without ever finding the object casting it. Eventually, with X-ray telescopes capable of peering through dust that visible light couldn't penetrate, astronomers found at least part of the answer. A massive collection of galaxy clusters, now called the Norma cluster, sitting roughly 250 million light-years away, anchoring a vast gravitational basin. But here's the part that still isn't settled. Even this discovery doesn't seem to account for everything. Something even larger may lie beyond it, an even bigger structure, sometimes called the Shapley supercluster, pulling on the Great Attractor itself, which is in turn pulling on us. So right now, this entire moment, this exact second, the Milky Way, our sun, this planet, and you, lying here listening, are quietly being dragged across the universe, at hundreds of kilometers every single second, toward a destination we still can't fully see, hidden behind our own galaxy's light, pulling us forward into a future shaped by a mass we've only ever felt and never truly looked at directly. Tabby's star and the alien megastructure theory. In 2015, a star roughly 1,470 light-years away started doing something that no star is supposed to do. It dimmed, not in the slow, predictable way stars normally do when a planet passes in front of them. It dimmed dramatically, sometimes by over 20%, in irregular, unpredictable patterns that didn't repeat, didn't follow any pattern astronomers had ever catalogued before. For comparison, a planet the size of Jupiter passing in front of its star usually causes a dip of about 1%. Something around this star was blocking over 20 times that amount. The star is officially named KYC 8462852, but it quickly picked up a nickname that stuck. Tabby's star, after Tabitha Boyajian, the astronomer who first brought its strange behavior to public attention. And almost immediately, the speculation turned to something that astronomers rarely say out loud with a straight face. What if the dimming wasn't natural at all? What if it was being caused by an enormous structure built deliberately by something intelligent? The idea isn't as wild as it sounds at first. Decades earlier, physicist Freeman Dyson proposed that any sufficiently advanced civilization, one that had outgrown its own planet's energy needs, might eventually build a massive structure around its star to capture as much of its energy as possible. A shell or a vast swarm of solar panels large enough to dim the star's light as seen from a distance. If something like that existed, partially built, irregular, still under construction, it might cause exactly the kind of strange, unpredictable dimming Tabby's star was showing. For a brief, genuinely thrilling moment, this wasn't fringe thinking. Serious astronomers at serious institutions pointed serious telescopes at this star, specifically checking for radio signals, for any sign that the dimming might be artificial. It was, for a short time, the most seriously considered alien megastructure candidate in the history of modern astronomy. Eventually, more mundane explanations took over. Follow-up observations suggested the dimming was likely caused by uneven clouds of dust, possibly from a shattered comet or a disintegrating moon, orbiting unevenly and unpredictably, blocking different amounts of light at different times. Not aliens, just messy, ordinary cosmic debris, doing something we hadn't seen quite this clearly before. But here's the part worth sitting with. For a little while, the most rigorous scientific minds on the planet looked at a flickering star and seriously asked themselves if they might be looking at evidence of someone else out there, building something enormous in the dark, light years away. And even now, faint, unexplained dimming events still occasionally show up. Just rare enough, and just strange enough, that no one has ever fully closed the door on the question. The WOW signal. On August 15, 1977, a radio telescope in Ohio, listening quietly for any sign of something out there, picked up a signal, not noise, not static, a strong, narrow, very specific burst of radio energy, lasting just 72 seconds, coming from the direction of the constellation Sagittarius. It was 70 times stronger than the normal background noise of space. The astronomer who found it later, scanning through the printout, circled the data in red pen and wrote one word beside it. Wow. That signal has never been explained. The telescope, part of a project called SETI, the Search for Extraterrestrial Intelligence, was specifically scanning a frequency known as the hydrogen line, a frequency many scientists believe an advanced civilization might deliberately use to broadcast a signal, precisely because it's a frequency that should be recognizable to any species that understands basic physics. And on that one night, on that exact frequency, something sent a signal so strong, so clean, that it matched almost perfectly what scientists had predicted an artificial transmission might look like. Here's the part that makes it so haunting. Astronomers checked everything: satellites, military transmissions, equipment malfunctions, reflections off space debris, even secret aircraft. Nothing matched. No human source, known or classified, could explain a signal with that exact shape, strength, and frequency. And the location it came from, that patch of sky in Sagittarius, has been searched again, repeatedly, by multiple telescopes, multiple times, across decades. Nothing has ever been heard from that direction again. Not once. A single clean, 72-second burst, then complete silence, for over 45 years. Some explanations have been proposed. A comet passing nearby, releasing a burst of hydrogen gas that briefly mimicked a radio signal, was suggested decades later, though most astronomers don't find it convincing given the exact characteristics of the signal. Others simply admit they don't know, and likely never will, because the moment is gone. There's no way to go back and re-examine it. There's only the printout, the red circled letters, and the silence that followed. So somewhere out there, in the direction of Sagittarius, something happened for exactly 72 seconds, once, that still matches, more closely than almost anything else ever recorded, what scientists believe an alien signal should look like. Maybe it was sent on purpose. Maybe it was an accident of nature we still haven't identified. Or maybe, just once, something out there said something, and by the time we turned to listen closer, it had already stopped talking, and never started again. Where did all the antimatter go? When the universe began, the laws of physics, as far as we understand them, should have created two things in exactly equal amounts: matter, the stuff that makes up stars, planets, and you, and antimatter, its strange mirror twin, identical in almost every way, except for one crucial difference. The moment matter and antimatter touch, they annihilate each other completely, converting entirely into pure energy, leaving nothing behind. So here's the problem that should genuinely unsettle you. If matter and antimatter were created in perfectly equal amounts at the beginning of everything, they should have run into each other almost instantly, cancelled each other out completely, and left behind a universe of pure light, energy, with no matter at all. No stars, no planets, no you. Just an endless, empty glow where a universe used to be. And yet, here you are. Somehow, when the dust settled in those first violent fractions of a second after the Big Bang, a tiny imbalance existed. For roughly every billion pairs of matter and antimatter particles that destroyed each other, one single particle of matter was left over, with no antimatter partner left to cancel it out. That leftover sliver, just one part in a billion, is the entire universe. Every star, every galaxy, every planet, every single atom in your body is made up of the tiny scraps that survived complete mutual annihilation, the leftover crumbs from a near-total act of cosmic self-destruction. Physicists have spent decades trying to figure out why that imbalance existed at all. The basic laws of physics, as far as we can test them, predict matter and antimatter should behave almost identically, which means they should have been created in numbers close enough to cancel out completely. Some experiments have found tiny, very specific differences in how certain particles decay, slight asymmetries that might explain a small piece of the imbalance, but not nearly enough to account for an entire universe's worth of leftover matter. The full reason, the actual mechanism that tipped the scales just enough to leave something behind, is still missing. So everything that exists, every thought you've ever had, every person you've ever loved, every star you've ever wished on, is built entirely from a rounding error in the early universe. A flaw, a tiny, unexplained crack in a process that should have erased itself completely. We are not the main event. We are the leftover residue of a cosmic explosion that was supposed to leave nothing behind, and somehow, quietly, impossibly, left just enough. The speed of light, as a cosmic prison light, moves at roughly 300,000 kilometers every single second. Fast enough to circle the entire Earth 7 times before you could even finish blinking. It sounds less like a speed limit and more like freedom itself. But the strange, quiet truth hiding underneath that number is that it isn't freedom at all. It's a wall built into the very fabric of the universe, and nothing, no matter how advanced, how clever, or how desperate, has ever found a way past it. Here's what most people get wrong about the speed of light. It isn't fast because we haven't built anything faster yet. It's fast because it appears to be the actual maximum speed that anything, information, matter, even cause and effect itself, is allowed to travel through the universe. Albert Einstein's equations show something deeply strange happens as anything with mass tries to approach that speed. It would require more and more energy just to go a little faster, until right at the edge of light speed itself, it would require an infinite amount of energy just to get there. Not difficult, not expensive, impossible. Now think about what that actually means for us. The nearest star system to our own sun is about 4.2 light-years away. Even traveling at the speed of light itself, which we cannot do, it would take over 4 years just to get there. Our own galaxy stretches across roughly 100,000 light-years. The nearest large galaxy beyond our own sits 2.5 million light-years away. Even if humanity built the fastest possible ship, one that somehow approached light speed itself, most of the universe would still remain functionally, permanently unreachable, simply because the distances are too vast and the speed limit is absolute. This is the quiet horror hiding underneath all those beautiful images of distant galaxies. We can see them. We can photograph them in incredible detail. We can calculate their distance down to the decimal, and we can never go there. Not in 1 lifetime, not in 100 lifetimes, not even if our entire species somehow survived for millions of years and dedicated every resource it had toward reaching them. The light from those galaxies took millions of years just to arrive here. The trip back would take just as long, and that's assuming you could even reach light speed, which the universe itself absolutely forbids. So the universe handed us an almost unimaginably large house, then quietly nailed shut every door except the one to our own small room. We can look out every window. We can see everything. We simply, permanently, are not allowed to leave. Quantum entanglement. Imagine taking 2 coins, separating them by the entire width of the universe, and flipping one. The instant it lands on heads, the other coin, sitting impossibly far away, with no signal, no connection, no possible way of knowing what happened, instantly lands on tails. Not eventually. Not after some delay, while information travels between them. Instantly. Albert Einstein hated this idea so much he gave it a name dripping with sarcasm. spooky action at a distance. And the unsettling part is, it's real, it's been tested, and it works exactly the way it sounds. This is quantum entanglement, and it happens at the smallest possible scale of reality, between particles like electrons or photons. When two particles become entangled, their properties become linked in a strange, deep way, so that measuring one instantly determines the state of the other, no matter how far apart they are. Separate them by a few meters in a lab, or theoretically by the width of the entire observable universe, and the connection doesn't weaken, doesn't fade, doesn't take any extra time to kick in. It just is, immediately, completely. The moment either one is measured, here's where it gets genuinely difficult to wrap your head around. Nothing is actually traveling between those two particles. No signal, no message, no tiny packet of information crossing the gap between them. If something were physically moving from one particle to the other, it would have to travel faster than light, which physics absolutely forbids. And yet the correlation is real, instant, and has been confirmed over and over in careful experiments specifically designed to rule out any other explanation. The particles seem to share a single, unified state, even while existing in two completely separate locations, as if distance, in some strange and fundamental way, doesn't fully apply to them. Scientists have spent decades trying to figure out exactly what this means about the nature of reality itself. Some believe it suggests the universe, at its deepest level, isn't made of separate, independent things at all, but is somehow deeply, invisibly connected underneath everything we can see. Others focus on the fact that entanglement, despite how strange it sounds, still can't actually be used to send a usable message faster than light, leaving the door open just enough that the rules of physics survive intact, even while looking deeply broken underneath. So somewhere, right now, a particle on one side of the planet or one side of the galaxy might be linked instantly and completely to its twin on the other side. Two objects, impossibly far apart, behaving for all purposes like a single thing, quietly hinting that the universe might be a lot less separate and a lot less distant than it ever appears to be. Supermassive black holes. At the exact center of nearly every galaxy in the universe, including our own, there is a hole in reality so deep that nothing, not light, not matter, not time itself, behaves normally anywhere near it. And it isn't some rare cosmic accident sitting quietly off to the side. It's the anchor, the quiet, invisible center that almost every galaxy seems to be built around, whether anyone living inside it ever notices or not. These are called supermassive black holes, and the numbers involved are almost impossible to hold in your head properly. The one at the center of our own Milky Way, called Sagittarius A star, has a mass equal to roughly 4 million suns crushed down into a single point, and ours is considered small. Other galaxies host supermassive black holes with masses in the billions, sometimes tens of billions, of times the mass of our Sun, anchoring galaxies far larger than our own. Here's the part that's genuinely strange. Despite that almost unbelievable mass, you could, in theory, orbit one safely, as long as you stayed far enough away, the same way Earth safely orbits the Sun. Gravity is gravity, no matter how extreme the source. The real danger isn't distance, it's getting close enough to cross something called the event horizon, the invisible boundary past which nothing, not even light, can ever climb back out again. Past that point, the rules don't bend. They break completely. Space and time themselves become so distorted that questions like, What happens next stop making sense in any way we can describe with normal language. And here's the detail that quietly reshapes how you think about galaxies. Most scientists now believe these supermassive black holes didn't just appear after a galaxy formed. They may have helped shape it from the very beginning, their immense gravity gathering gas and dust, sparking star formation, quietly directing the structure of everything orbiting around them, the same way a single central idea can shape an entire life built up slowly around it. So right now, while you lie here, our entire solar system, the sun, the planets, this exact room, is slowly orbiting around an invisible monster sitting roughly 26,000 light-years away at the dead center of our galaxy. Something with the mass of 4 million suns, completely invisible, completely silent, holding the structure of everything we have ever known in a quiet, patient, gravitational grip we will never see directly and can never escape. Olber's paradox. Look up at the night sky, and you'll see darkness with a scattering of bright points breaking it up here and there. It feels obvious. It feels normal. But sit with the question long enough, and it stops making sense. If the universe is infinite, or even just impossibly vast, filled with countless stars stretching out in every direction, then every single point in the sky, no matter where you look, should eventually land on a star. The night sky shouldn't be dark at all. It should be a wall of solid light. This is called Olber's paradox, named after the astronomer who took the question seriously enough to turn it into a real problem. Picture it like standing in the middle of an endless forest. Look in any direction, and no matter how far your eyes travel, eventually a tree blocks your view. There are simply too many trees stretching too far for any gap to exist. If stars are scattered through an infinite universe the same way, every gap between them should eventually be filled by some star, somewhere, far enough away. The night sky should be blinding. Instead, it's mostly black, with stars as just rare little punctures in the dark. For a long time, this genuinely confused scientists, because it seemed to suggest something was deeply wrong with our picture of the universe. Either it wasn't infinite, or stars weren't distributed evenly, or something else, something stranger, was quietly stopping all that light from ever reaching us. The real answer turned out to be almost more unsettling than the paradox itself. The universe has a finite age. Light from extremely distant stars simply hasn't had enough time yet to travel all the way to Earth, even after 13.8 billion years. So instead of being filled with starlight from every possible direction, the night sky is filled with gaps, places where a star's light is technically out there, somewhere, still slowly making its way toward us, but hasn't arrived yet, and might not arrive for billions more years. And there's a second piece. The universe is expanding, stretching distant starlight out into wavelengths our eyes simply can't see, fading it into invisible infrared and microwave light long before it ever reaches us, dimming entire regions of stars into total darkness, not because they aren't shining, but because their light, by the time it gets here, no longer counts as light at all. So when you look up at a dark sky, you're not looking at an empty universe. You're looking at an unfinished one, a vast, glowing forest of stars, with most of the light still, even now, quietly traveling toward you, somewhere out in the dark, simply not arrived yet. The great filter that might be erasing civilizations. Somewhere between simple chemistry and a civilization capable of reaching the stars, something seems to go wrong. Not occasionally, not by accident, almost universally. And whatever that something is, it might already be sitting directly in humanity's path, quietly waiting, whether we've passed it already or not. This is the idea behind the Great Filter, a theory built to explain the same uncomfortable silence we've already talked about. The fact that despite billions of stars and billions of years, we've never found any solid proof that another civilization has ever existed. The Great Filter is the proposed explanation. Somewhere along the long road from lifeless chemistry to a civilization capable of spreading among the stars, there's a step, or maybe several steps, that almost nothing manages to survive. Life might be common, thinking technological life might be vanishingly rare simply because something keeps stopping it before it gets very far. Here's the part that should genuinely unsettle you. Nobody knows where the filter actually is. And depending on where it sits, the meaning changes completely. If the filter is somewhere behind us, some incredibly difficult step like the formation of the first living cell, or the leap from simple life to complex life, then we got impossibly lucky already. We survived the hardest part. The road ahead might actually be open. But if the filter is somewhere ahead of us, still waiting, then every sign of intelligent life we've never found isn't proof that the universe is empty. It's proof that something, almost without exception, stops civilizations like ours before they ever get the chance to expand beyond their own planet. And the candidates for what that filter might be are not comforting. Nuclear war, engineered pandemics, runaway artificial intelligence, climate collapse, resource exhaustion, the quiet, grinding possibility that intelligence itself, the very thing that lets a species build telescopes and ask these questions in the first place, might also be the thing that reliably builds the tools of its own ending. So the silence in the sky stops feeling empty and starts feeling like evidence. Not proof that no one else tried. Proof, maybe, that almost everyone who tried met the same wall we might be approaching right now, without even realizing we're close enough to touch it. If the filter is behind us, this entire conversation is simply us looking back at a finish line we already crossed by sheer chance. But if it's ahead, somewhere in the unknown space between where we are now and where the stars are waiting, then the real question was never about anyone else out there. It was always, quietly, about how much further we have left to go, and whether anything we do between now and then will be the very thing that decides if we get to keep going at all. Vacuum decay. Right now, you're picturing empty space as exactly that. Empty. Nothing happening, nothing changing. Just quiet, harmless emptiness stretching out between stars. But there's a small, genuinely serious possibility that empty space isn't as stable as it looks, that the universe might be sitting in a kind of false calm, like a ball resting on a ledge instead of all the way at the bottom of a hill. And if that's true, then somewhere, at some unknown moment, it could simply let go. This is called vacuum decay, and it comes from a strange property of the universe called the Higgs field, the same field that gives particles their mass. Physicists describe this field as sitting in a particular energy state right now, one that allows stars, atoms, and chemistry to work exactly the way they do. But some calculations suggest this current state might not be the lowest possible energy state available. It might just be a comfortable, temporary resting spot, what physicists call a false vacuum, sitting on a ledge above a much deeper, more stable valley. Here's the part that's almost too strange to fully picture. If that's true, then somewhere, at some random point in space, completely without warning, a tiny bubble of true vacuum could form. Inside that bubble, the laws of physics themselves would be different. The masses of particles, the strength of forces, the basic rules holding atoms together, all of it would shift into a new configuration. And the moment that bubble forms, it wouldn't stay small. It would expand outward in every direction, at very close to the speed of light, rewriting the laws of physics everywhere it touched. There would be no warning. Because the bubble expands at nearly light speed, you would never see it coming. The light announcing its arrival would reach you at almost exactly the same instant the bubble itself did. One moment, everything is normal. The next, and there genuinely would be no perceivable next, the fundamental rules of chemistry stop applying. Atoms can no longer hold together the way they used to. And everything, stars, planets, every structure in existence, simply stops working. All at once, everywhere the bubble reaches. Physicists studying this generally believe it's unlikely to happen anytime soon, if it happens at all, and there's nothing anyone could do to prevent it regardless. So it sits there quietly in the math, an almost forgotten possibility, that the comfortable, stable universe you've lived in your entire life might simply be balanced delicately on a ledge, with no guarantee and no warning of how long that ledge will hold. The Pioneer Anomaly. In 1972, NASA launched a small spacecraft called Pioneer 10, sending it out past Jupiter and eventually beyond the edge of the solar system entirely, the first human-made object to ever leave our planetary neighborhood for good. A few years later, its twin, Pioneer 11, followed the same path. Both were simple, almost old-fashioned by today's standards, and both, decades into their journey, started doing something that quietly puzzled scientists for years. They were slowing down, just slightly, just barely measurably, but slowing down more than they should have been. Spacecraft drifting through deep space should follow predictable rules. Once they're far enough from any planet's gravity, their speed should only change based on the sun's pull, weakening steadily and predictably the farther they travel. Engineers tracked both Pioneer probes using the faint radio signals they sent back to Earth, signals precise enough to detect speed changes far too small to ever notice directly. And starting sometime in the 1980s, both spacecraft, independently, on opposite sides of the solar system, began drifting slightly slower than the math said they should. The anomaly was tiny, less than 1 nanometer per second, every second, an amount so small it would take years to add up to anything measurable at all. But it was consistent. It showed up in both spacecraft. It didn't fade away, and for a long time, nobody could explain it using any known force acting on the probes. And once mainstream physics runs out of easy answers, the explanations start getting interesting. Some wondered if it hinted at a flaw in our understanding of gravity itself, some subtle correction needed at the edge of the solar system that nobody had ever needed to measure before. Others wondered if dark matter, draped invisibly throughout the solar system, was creating just enough extra pull to slow the probes down. For years, this was a real, seriously discussed possibility, a tiny irregularity that might be pointing toward something genuinely new about the universe. Eventually, the answer turned out to be far less cosmic and almost disappointingly human: heat. The spacecraft's own power systems, slowly decaying over decades, were radiating heat unevenly off the body of the probes themselves, creating an incredibly faint, lopsided push, like an almost invisible thruster running backward, slowing the ships down by the tiniest possible amount, completely by accident. So in the end, it wasn't dark matter. It wasn't broken physics. It was warmth, leaking unevenly off an aging machine, in the freezing dark, beyond the edge of the solar system. But for years, before that answer was found, two of humanity's most distant creations were quietly behaving in a way nobody could explain, slipping slower into the dark for reasons that, for a little while, nobody on the entire planet could name. Could the universe be a black hole? Here's a question that sounds like it shouldn't even be allowed to make sense, and yet physicists have taken it seriously enough to write papers about it. What if the universe itself, the entire thing, every star, every galaxy, every atom you've ever known, is sitting inside a black hole, viewed from some other reality, completely outside our own? It starts with a strange coincidence in the math. Black holes have something called a Schwarzschild radius, a size determined entirely by how much mass and energy is packed inside them. If you take the total estimated mass and energy of our entire observable universe and calculate what size a black hole containing that much mass should be, the number that comes out is suspiciously, uncomfortably close to the actual size of the observable universe itself. Almost as if the universe is exactly the size you'd expect if it were, in fact, the inside of a black hole. Here's where it gets genuinely strange to picture. Some physicists have proposed that what we experience as the Big Bang, the explosive birth of our entire universe, might actually look completely different from the outside. From outside, it might simply look like an ordinary star, collapsing under its own gravity, the way stars do at the end of their lives, forming a black hole. But instead of crushing down into an infinitely small point, the way we usually imagine, some theories suggest that collapsing matter might instead bounce violently into an entirely new expanding space on the other side, a space that the outside universe would never see, because it would be sealed away behind the black hole's event horizon. From the outside, just a black hole sitting quietly in space. From the inside, a brand new universe, expanding, cooling, eventually filled with stars, galaxies, and entire histories, with absolutely no way of looking back out to confirm where it came from. If this is true, then every black hole we've ever observed in our own universe, every one of those crushing, invisible monsters at the center of galaxies, might not be an ending at all. Each one might be a doorway, quietly, violently giving birth to an entire new universe on the other side, with its own laws, its own stars, its own civilizations, eventually looking up at their own sky, with absolutely no way of knowing they're living inside something their own universe would call a black hole. So somewhere outside everything you've ever known, in a reality you will never reach, never see, and never prove exists, there may be a sky with a quiet, invisible point of darkness sitting in it. And everything you have ever loved, every star, every person, every breath you've ever taken, might simply be happening, completely unnoticed, inside that single, distant point. The day Earth will be swallowed by the sun. Right now, the sun rises every morning, gives you warmth, grows your food, and feels like the most permanent, dependable thing in your entire life. It has shone exactly the same way for your entire existence, and for every existence before yours, stretching back further than memory itself. But the sun is not permanent. It is slowly, patiently, burning through a finite supply of fuel, and one day, billions of years from now, it will finish the job it started by ending the very planet it once made possible. Here's how it actually happens. In roughly 5 billion years, give or take, the sun will run out of hydrogen fuel in its core. Without that fuel keeping it stable, gravity will finally win the argument it's been quietly losing for billions of years, and the sun will begin to collapse inward, which sounds like an ending, but is actually a beginning of something far worse. That collapse will heat the core enough to start burning a different fuel, helium, and that new burning will cause the outer layers of the sun to swell outward dramatically, becoming what's called a red giant, not slightly bigger, enormously bigger, large enough, according to most calculations, to expand outward past the orbit of Mercury, past Venus, and quite possibly far enough to swallow Earth completely. And even if Earth somehow survives being physically engulfed, which is genuinely still debated, it won't matter. Long before the sun even reaches that swollen, monstrous size, its growing heat will have already boiled away every ocean, stripped away the atmosphere, and turned the entire surface of this planet into a barren, scorched wasteland, completely incapable of supporting anything resembling the life that exists here right now. Here's the part that's strangely difficult to sit with. Every person who has ever lived, every war fought, every love story, every small private moment that felt important enough to remember, all of it happened on a planet that has an expiration date already written into the laws of physics. Not a maybe. Not a risk we might avoid through careful planning. A certainty, already guaranteed by the simple, patient burning of hydrogen happening 93 million miles away, right now while you lie here listening to this. 5 billion years is an almost meaningless number to a human mind. It's longer than life has even existed on Earth so far. But it's still a number, still a countdown, quietly ticking forward every single day, toward an ending that the sun, the very thing that made life possible in the first place, will eventually deliver itself, slowly, patiently, the same way it's been giving us everything else, all along. Neutrinos. Right now, trillions of tiny particles are passing straight through your body, through your skin, your bones, your heart, completely unnoticed, leaving behind absolutely no trace, no damage, no sensation of any kind. You will never feel them. You will never see them. And yet they are moving through you right now, every single second, in numbers too large to properly imagine. These are called neutrinos, sometimes nicknamed ghost particles, and they might be the most antisocial things in the entire universe. They have almost no mass, no electric charge, and almost no interest in interacting with anything else at all. Most particles bump into things, get absorbed, get deflected, leave some kind of mark on the matter around them. Neutrinos do almost none of that. They could pass through a wall of solid lead a light year thick, and most of them would make it through completely untouched, as if the lead simply wasn't there. Here's where they come from. The sun produces them by the trillions, every single second, as a byproduct of the nuclear fusion happening deep in its core, the same fusion that gives you sunlight and warmth. Those neutrinos travel outward instantly, completely unaffected by the sun's crushing density, slipping through millions of miles of solar material as easily as light passes through glass. Then they cross the 93 million miles of empty space between the sun and Earth, and pass straight through the entire planet, through solid rock, through oceans, through cities, through you, without slowing down even slightly. To actually catch one, scientists had to build some of the strangest detectors on Earth. Massive tanks filled with thousands of tons of ultra-pure liquid, buried deep underground or under mountains, specifically to block out every other kind of particle, waiting patiently for the incredibly rare moment when one single neutrino, out of the trillions passing through, happens to bump into something and leave behind a tiny, detectable flash of light. Most experiments catch only a small handful of confirmed interactions per day, despite unimaginable numbers of neutrinos pouring through the detector every single second. So somewhere, right now, while you lie completely still, a particle born inside the sun 8 minutes ago is passing silently through your chest, through your heart, through the exact center of your body, completely unnoticed, continuing on its way through the earth beneath you, out the other side, and back into the dark, completely unaffected by you, by the planet, or by anything else standing in its way. The cosmic web. Zoom far enough away from Earth, past the planets, past the galaxy, past entire clusters of galaxies, and the universe stops looking random. It starts looking like something built. Threaded through the dark, stretching across billions of light years, there is a vast, glowing structure connecting almost everything that exists, and most people never even hear about it. Scientists call it the cosmic web, and it might be the closest thing the universe has to a skeleton. Picture countless strands of gas and dark matter, stretching out across unimaginable distances, crossing and connecting at certain points, the way threads of a spider web meet at specific knots. Where those strands cross, gravity pulls matter together, slowly, over billions of years, gathering enough material to ignite stars, build galaxies, and eventually form massive galaxy clusters sitting right at the intersections. Galaxies aren't scattered randomly through space like sand thrown across a table. They're arranged along this invisible scaffolding, clustered at the nodes, strung out along filaments, leaving enormous, nearly empty gaps, called cosmic voids in between. Here's the part that quietly reframes everything. Our entire galaxy, the Milky Way, isn't floating freely in open space. It's sitting on one strand of this enormous structure, part of a long filament of galaxies stretching out across hundreds of millions of light years, connected, gravitationally, to galaxies we will never visit, never see in detail, and never fully understand, simply because the scale is too large for any single mind, or even any single civilization, to ever fully map. And most of this structure is invisible. The glowing galaxies you can actually see in a picture of the cosmic web are just the visible decorations sitting on top of something far larger and completely dark, vast filaments of dark matter stretching between galaxies, providing the actual gravitational scaffolding that holds the entire structure together. The light is just the part we happen to be able to see. The structure itself is built from something we still can't directly detect. So you are not simply standing on a planet, orbiting a star, inside a galaxy. You are standing on a single point of light, strung along one strand of an almost incomprehensibly vast web, stretching across the entire universe, connected by gravity to galaxies you will never know the names of, sitting on a structure so large that comprehending its true shape may always remain just slightly out of reach for any mind small enough to be standing inside it. Rogue black holes, drifting through Milky Way. Most black holes stay where you'd expect them, anchored at the center of galaxies, or quietly orbiting within a binary star system, predictable, traceable, accounted for. But scientists now believe our own galaxy is quietly filled with black holes that don't follow any of those rules at all, invisible, untethered, drifting silently through the dark, with no star, no light, and no warning to announce that they're even there. These are called rogue black holes, and they're created the same violent way most black holes are born, when a massive star runs out of fuel and collapses in on itself. But sometimes that collapse isn't perfectly even. The resulting explosion can give the newborn black hole a powerful kick, like a recoil, sending it flying off into space at incredible speeds, completely free of whatever system it was born in. Once that happens, there's nothing left to orbit, no star pulling it back, no anchor holding it in place. It simply drifts, alone, through the galaxy for the rest of its existence. Here's the part that should genuinely unsettle you. Scientists estimate there could be over 100 million of these isolated black holes wandering through our galaxy alone. Not at the center. Not in some distant cluster. Scattered throughout the Milky Way, potentially passing through regions far closer to our own solar system than most people would ever guess. And the unsettling part isn't really their danger, since space is mostly empty and the odds of one passing close enough to matter are astronomically small. It's the fact that we would have almost no way of knowing one was nearby until it was almost too late. A rogue black hole emits no light. It isn't surrounded by glowing matter, the way black holes near a feeding source often are. It doesn't announce itself with X-rays or visible distortion unless something happens to be drifting close enough to be pulled in and heated up first. The only way astronomers have ever managed to detect one is through something called gravitational microlensing, watching for the extremely subtle, temporary bending of light from a distant star caused by an invisible mass passing directly between us and that star. A flicker, a brief distortion, and then nothing. The black hole continuing on its way, completely undetected for the rest of its silent journey through the galaxy. So somewhere out there, right now, scattered invisibly across our galaxy, dozens, possibly millions, of collapsed stars are drifting silently through the dark, completely undetectable unless they happen to pass in front of exactly the right star, at exactly the right moment, for us to catch the briefest flicker of proof that something invisible and unaccounted for just quietly passed by. The universe's missing first billion years. For decades, astronomers built a fairly tidy timeline of how the universe grew up. The Big Bang happened, things cooled down, and then, slowly, patiently, over hundreds of millions of years, gravity pulled together the very first tiny, faint, unimpressive galaxies. Small, simple, exactly what you'd expect from a universe still finding its footing. Then, in late 2021, a new telescope launched that was finally powerful enough to actually look back and check that story directly. And almost immediately, the story stopped making sense. The James Webb Space Telescope was built specifically to peer further back in time than any instrument before it, by catching extremely faint, ancient light that had been stretched out over billions of years of cosmic expansion. Astronomers pointed it toward the earliest possible moments after the Big Bang, fully expecting to find exactly what the old timeline predicted: small, dim, barely formed galaxies, just beginning to take shape. Instead, they found galaxies that were already big, already bright, already surprisingly mature, sitting in a part of the universe's history where almost nothing that organized should have existed yet. Here's the part that genuinely shook astronomers. Some of these galaxies appeared to have grown far too massive, far too quickly, sometimes looking like they'd had hundreds of millions of years longer to develop than the timeline allowed for. It was like looking at baby photos of someone, expecting to see an infant, and instead finding a fully grown teenager already standing there, in a photo clearly dated to right after their first birthday. Astronomers are still working through what this actually means. Some think our models of how quickly gas collapses into stars and galaxies in the early universe simply need correcting, that the early universe was more efficient at building large structures than anyone expected. Others wonder if our measurements of distance and age for these extremely far objects need refining, since measuring anything this old, this faint, and this far away pushes our instruments right to the edge of what they can reliably detect. And a few, more provocatively, wonder if something deeper about the early universe's timeline, maybe even the rate of cosmic expansion itself in those first chaotic moments, isn't fully understood yet. So somewhere in that earliest sliver of cosmic history, in a stretch of time we always assumed was simple, quiet, and unremarkable, something was apparently happening far faster, far earlier, and far more efficiently than anyone had predicted. And right now, astronomers are still staring at those impossible baby photos, trying to figure out how something got so big, so fast, in a universe that was supposed to still be barely getting started. Are the laws of physics the same everywhere? Every equation you've ever learned, every formula describing gravity, light, or atoms, carries with it a quiet, almost invisible assumption that the laws governing it here, in this room, on this planet, are exactly the same laws governing the farthest edge of the observable universe, billions of light years away, in galaxies we will never visit. It's the kind of assumption so basic that most people never even realize it's being made. And in recent years, a handful of careful, unsettling measurements have started to ask whether that assumption is actually true. One of the most basic numbers in all of physics is something called the fine structure constant, a number that determines how strongly light interacts with charged particles like electrons. It shows up almost everywhere: atoms, chemistry, the colors stars emit when they burn. For most of scientific history, it's simply been treated as fixed. The same number, everywhere, for all of time. But by studying extremely distant light that left its source billions of years ago, before reaching our telescopes today, some researchers have reported tiny, controversial hints that this number might shift ever so slightly, depending on where and even when you measure it. Here's what that would actually mean if it turned out to be true. If the fine structure constant is even fractionally different in some distant corner of the universe, then the basic rules governing how atoms bond, how stars burn, how chemistry itself functions, could be subtly different there too. Not wildly different, not different enough to make galaxies unrecognizable, but different enough that the universe wouldn't actually be one single, uniform rulebook stretching infinitely in every direction. It would be something closer to a patchwork, mostly consistent, but with faint, almost undetectable seams, stitched together imperfectly across unimaginable distances. Most physicists remain cautious here, and for good reason. These measurements sit right at the edge of what our instruments can reliably detect, and several follow-up studies have failed to confirm the early hints, or found them so small they could simply be measurement error. The honest current answer is that we don't know, and proving it firmly, in either direction, would require precision that pushes against the absolute limits of what we can currently measure across billions of light-years of distance and time. So for now, the universe still appears as far as anyone can prove, completely consistent, the same patient rules holding everywhere you look. But that quiet, careful uncertainty hiding underneath the data leaves the door open to something stranger. The possibility that the rulebook you've trusted your entire life isn't quite as universal as its name suggests, and that somewhere out there, the universe might be playing by slightly different rules than the ones written down right here. The hum of gravitational waves. Space itself can ripple, not metaphorically, actually stretch and compress the way the surface of a pond ripples outward after a stone breaks the surface, except the pond, in this case, is the literal fabric of space and time, and the stone is something almost too violent to properly imagine, like two black holes spiraling into each other and finally colliding. These ripples are called gravitational waves, and Einstein predicted them over a century ago as a direct consequence of his theory of general relativity. According to that theory, massive objects don't just sit in space, pulling on things nearby. They actually bend the space around them, and when something massive enough accelerates violently, two black holes crashing together, two dead stars colliding, that bending doesn't stay still. It ripples outward, stretching and squeezing space itself as it travels, carrying the violence of that event outward in every direction, forever, fading but never fully stopping. For decades, this stayed purely theoretical, because the effect, by the time it reaches Earth, is almost unimaginably small. We're talking about a stretch in space smaller than the width of a single proton, spread across a detector stretching for miles. In 2015, scientists finally built instruments precise enough to catch it. Two facilities, thousands of miles apart, both detected the exact same impossibly tiny ripple, arriving at the exact same moment, confirming that over 1 billion years ago, two black holes had collided somewhere out in deep space, and the literal shape of space itself, at that exact location, had been stretched and squeezed by the impact, with that distortion finally arriving here, on Earth, more than 1 billion years after it began. Here's what's strange to sit with. That collision happened so long ago that the black holes involved had already finished merging before our own solar system had even formed. The signal had been traveling, quietly, patiently, through the depths of space for that entire time, completely unnoticed, until it finally reached a planet that hadn't even existed yet when the collision occurred, and a species on it that had only just learned how to listen for something this faint. So underneath everything you've ever experienced, every quiet, motionless moment lying here right now, space itself has been gently rippling the entire time, carrying the echoes of ancient collisions across the universe. We simply never had ears sensitive enough to hear it until very recently, when we finally built something capable of feeling the universe quietly humming with the leftover violence of its own distant past. What lies beyond the edge of a black hole? Cross a certain invisible line near a black hole, and the universe stops negotiating. There's no warning sign, no resistance, nothing that would even feel unusual in the moment. You would simply pass through it, calmly, and from that instant onward, leaving would no longer be a question of effort. It would be a question of physics flatly refusing to allow it. That line is called the event horizon, and it isn't a physical surface. It's a boundary, a point of no return, where gravity becomes so overwhelming that the escape speed needed to get back out exceeds the speed of light itself. Since nothing can travel faster than light, nothing that crosses this line, not light, not matter, not information, can ever climb back out again. Whatever happens beyond it stays beyond it, permanently, sealed away from the rest of the universe. Here's where it gets genuinely strange. From the outside, looking in, you would never actually see someone fall in. As they approached the event horizon, the immense gravity would stretch time itself for them, slowing their fall, from your perspective, more and more, until they appeared frozen, fading, dimming, stuck forever at the edge, never quite completing the crossing. At least as far as you could ever tell from where you're standing. But from their own perspective, falling towards the black hole, nothing would feel slow at all. They would cross that boundary in an ordinary, unremarkable instant, completely unaware of the precise moment it happened, since there's no signal, no flash, no marker announcing the crossing from the inside. And then, deeper in, you reach what current physics treats as the actual heart of the problem. The singularity, a point where, according to general relativity, gravity becomes infinite. Space and time stop behaving like space and time at all, and the equations we use to describe the universe simply break down completely. Nobody actually knows what exists there. Some physicists suspect the singularity isn't truly infinite, that it's a sign our current theories are incomplete, missing some deeper rule that would replace that impossible infinity with something stranger, but at least finite. Others entertain even stranger possibilities, that the singularity might connect to another point in space and time entirely, a theoretical shortcut some call a wormhole, though nothing has ever confirmed that such a thing is physically real. So somewhere out there, scattered through the galaxy, there are places where falling in looks completely different, depending on whether you're the one falling or the one left behind watching, and where, at the very center, hidden behind a boundary nothing can ever cross back out of, our best equations simply stop being able to tell us what's actually there. The possibility that the universe is infinite. Try, for a moment, to actually picture infinite space. Not a very large number, not a distance so big it might as well be infinite, actually, literally endless, stretching outward in every direction, forever, with no edge, no wall, no final star marking the boundary where everything simply stops. Most minds, including yours right now, will hit a wall trying to hold that idea steady. Not because it's wrong, but because nothing in your entire life has ever prepared you to imagine something with no edge at all. Here's the strange part. As far as we can currently measure, the universe might actually be infinite, not metaphorically, not as a poetic way of saying very big. Genuinely, mathematically endless. Measurements of the universe's overall shape, something called its curvature, suggest that space is extremely close to perfectly flat, and a perfectly flat universe, under most models, stretches on forever in every direction, with no boundary anywhere, ever, no matter how far you traveled. If that's true, the implications get strange almost immediately. An infinite universe filled with stars and galaxies wouldn't just contain a lot of matter. It would contain every possible arrangement of matter that the laws of physics allow, repeating over and over an infinite number of times. Somewhere out there, impossibly far beyond anything we could ever observe or reach, there could be another planet identical to Earth, down to the smallest detail. Another version of this exact room. Another version of you, lying in the exact same position, hearing the exact same words, at the exact same moment. Not because of fate or destiny or anything mystical. Simply because, given truly infinite space and a finite number of ways particles can arrange themselves, every possible arrangement, no matter how specific, would eventually repeat. Not once, infinitely many times. And here's the part that quietly reframes the entire idea. We will never know if any of this is actually true. The observable universe, the 46 billion light-year bubble we are capable of seeing, might only be an infinitesimally tiny fraction of something endless, stretching out forever past the edge of what light could ever show us. We are, in that case, standing in a room with no visible walls, trying to determine whether the room is simply very large or doesn't end at all, using tools that can only ever measure the small, local patch of floor we happen to be standing on. So somewhere beyond every star you've ever seen, beyond every galaxy ever photographed, space might simply keep going, forever, repeating itself endlessly, including, somewhere out there, a moment exactly like this one, happening again, and again, and again, for reasons no edge, no wall, and no end could ever explain.